Okay, today we're starting Chapter 2, Section 4, Parallel and Perpendicular Lines. And let's see, let's try to move this out of the way. Funny enough, I have a cousin. He goes to Hendersonville High School, and he's actually going over this as well. So there's that. Alrighty, I wish this would disappear. Maybe I need to check my chat. Ah, that's what it was. Okay. Alrighty, so let's see. We know that parallel lines do not intersect. Right? They're lines that go on and on and on and on and on and on forever without actually crossing one another. Alrighty, and it says to review this concept, refer back to section 2.3. Because parallel lines don't intersect, the ratio of the vertical change, which is the rise, and the horizontal change, which is the run. So when it says the ratio, basically just a fraction, right? They have the exact same slope. Okay, of course we know that because they're parallel lines, right? So if two lines are parallel, they will have the same slope. And of course that's what our theorem down here says. Two distinct non-vertical lines in the Cartesian plane are parallel if and only if they have the same slope. By the way, this if and only if statement, okay? The if and only if statement in in logic, not just mathematics, but you come across it a lot in mathematics. What it means is that you can pretty much read the sentence forward and backwards. So we could obviously read it from left to right, the way we originally read it, or we could say they have the same slope if and only if two distinct non-vertical lines in a Cartesian plane are parallel. So that's what the if and only if means. It just basically means you can read things. You can read the statement forward and backwards, and it was logically sound. Alrighty. So show that the lines y is equal to negative 2/3 x minus 1 and 4x plus 6y equals 12 are parallel. Okay, well, let's do this. We're going to denote this equation in blue and this equation in yellow. Okay, so what is the slope for the equation in blue? Well, it's pretty easy. It's already given to us, right? It's in slope-intercept form, so the slope in blue is negative 2/3. I was just going to say, don't put x, and I wrote x. But yeah, the slope is negative 2/3. It's not negative 2/3 x, okay? X is just our variable. The slope is the number in front of the variable, okay? Well, now, what do we have to do for the equation in yellow? Well, let's just solve it for y. That's it, right? So let's go ahead and start this out by subtracting 4x from both sides. So we're going to have 6y is equal to negative 4x plus 12. Okay, then we're going to divide both sides by 6, and so we're going to end up with y is equal to a negative, and we'll just not fix the fraction just yet, plus 2. Then we've got y is equal to negative 2/3 x plus 2. Okay, and then notice how the slope is negative 2/3, the same as the first slope. Okay. And that's it. That we just showed that these two lines are indeed parallel to one another. Okay, pretty easy stuff. All right. Next, we're going to talk about perpendicular lines. Now, this says a lot of stuff, but I'm just going to touch on the high points that we're interested in. Actually, first of all, this definition isn't my favorite because, first of all, it's not what I mean, it is, but it's not the form, the vernacular that I remember. Okay, and I'm pretty sure you guys have heard perpendicular slopes are negative reciprocals, right? So this theorem here, while it is true, it's a very true statement, right? It says two non-vertical lines in the Cartesian plane are perpendicular if and only if there's if the product of their slope is -1, and that makes sense because whenever you multiply the two products together, you will indeed get -1. For instance, let's see. So if this blue line has a slope of a over b, and the red line has a slope of negative b over a, right? Again, we know that as negative reciprocal. The signs are different. One's positive, one's negative, and the fraction is flipped, right? One is a over b, one is b over a. Again, negative reciprocal, how I was taught, how you've probably been taught. But the theorem that we do see is indeed a true statement, because if we multiply, we'll just do a little quick math over here. AB times a negative b over a. Well, obviously the b is canceled, the a is canceled, it just becomes 1, and then it's just all negative 1. Right? So it does indeed make sense. It's just, again, not what we were probably used to. So I will stick with negative reciprocal. That's fine. And again, just to reiterate, when I say negative reciprocal, basically if the slopes have different sign, okay, that's check 1, and the fraction of the slope, the ratio of the slope, is inversed, that's check 2. Okay, so let's do an example. All right, it looks like both of these I'm actually going to have to work out, so that's good. Didn't really like that example 1 where I didn't have to work it out. All right, so again, we're going to denote this one as blue and this one as yellow. Okay, so we're going to start off by solving for y in the blue, so let's go ahead and subtract 3x on both sides. So we're going to have a negative 6y is equal to a negative 3x minus 12. We're going to divide both sides by a negative 6. So we're going to say y is equal to, all right, so, well, no, let's not do that. All right, so we're going to have y is equal to, and then negative 3 over negative 6, all right, that's going to be a positive, well, let's just do this. We'll do positive 3, 6. We're not going to jump ahead of ourselves a little bit. And then it's going to be plus 2. Okay, and then we're going to fix that fraction. Oh, it's supposed to be negative 6. Negative 3 halves x. Sorry about that. Plus 2. And then we're going to reduce that fraction, so it becomes a 1/2 x plus 2. Okay, so the slope of our first equation is going to be positive 1/2. Okay. All right, now let's do the second equation. Again, let's just start off by subtracting 2. Well, it's pretty easy. We're going to subtract 2x from both sides. So this is going to end up being y is equal to a negative 2x plus 4. And they might have well just given to us, right? It's pretty easy. And this slope is negative 2. Okay, so looking at the two numbers that I put that green box around, the sign is indeed different, check, and the fraction is indeed flipped, right? One is 1/2, and the other, the 2 is, it's 1/2 flipped, right? It's 2 over 1, right? So these lines are indeed perpendicular to one another because it is indeed the negative reciprocal. Okay. And then this would be, I guess, would be a summary. Okay. That's not too hard. All right, it's just a summary of what we just talked about. Let's see, any two distinct vertical lines are parallel. Yeah. Just what we just went over. Interesting, the summary is there. Okay. Alrighty, so. Alrighty, from the top, given any two distinct lines, we are now able to quickly determine whether the lines are parallel to each other, perpendicular to each other, or neither by simply evaluating their slopes. And again, those are your three options: parallel, perpendicular, or neither. That's it. Those are your three options. It's going to be one of those three, right? Alrighty, so let's start with A. We'll go ahead and put A in white. Okay, so let's go ahead and starting here. Let's go ahead and solve for y. So it looks like we're gonna have a negative. Let's make sure we denote that as a. We're gonna have a negative y is equal to a negative 3x plus 4. Right. And then we're going to multiply by negative 1 on both sides. So we're going to end up with a y is equal to a 3x minus 4. Okay, so that's the first equation. The second equation, we're going to subtract. For the sake of this, let's just go ahead and use up a lot of sheets. I don't want to get this a little congested. So let's go ahead and subtract x from both sides. We're going to have 3y is equal to a negative x plus 7. Subtract or divide, excuse me, divide both sides by 3. We're going to have y is equal to, that's going to be negative 1/3 x plus 7/3. Okay, and again, looking right here at the slope. Okay, so are the signs different? Yes, check. Are they inverses of one another? Check. Okay, so this one, so A must be perpendicular. Okay, so we're going to write perp. Right, let's go to B. Alrighty, so B. Well, heck, the first one's already done it for us. That's awfully nice of the textbook. Okay, and of course our slope here is a positive 1/2. And then down the next one, we're going to go ahead and subtract x from both sides. So we're going to have 2y is equal to negative x plus 1. We divide both sides by 2. So we're going to have y is equal to a negative 1/2 x plus 1. Looking at this. Okay, so are they, are the signs different? Yes, check. Is the fraction inversed? No, it's the same fraction. One of them's 1/2 and the other's 1/2, right? So this is going to be neither. Okay, so neither. And I bet, oh, that is, I bet C would be parallel, right? Because, I mean, we did perpendicular, we have a neither, so we do indeed see that they're parallel because we learned this at the end of last section, right? C, x equals -1, well, that's a vertical line at -1, and x equals 3 is a vertical line at 3. So if you forgot, right, we have 1, 2, 3, 4, 1, 2, 3, 4, right? So at x equals -1, we have a vertical line, right? This is x is equal to -1. And then at x equals 3, well, okay, one more try. All right, whatever. I think I forced that, but that's okay. At x equals 3, we have a vertical line, and we do indeed have parallel lines. Okay, so C will be parallel. I always like writing parallel. That's it. All right, now we get to the fun part where we have to find an equation, right? So similar to what we did with the circles, where we had to find equations with the circles, we're going to be finding equations here, okay? So here we go. This reads, find the equation of the line parallel to the line 2x plus 4y is equal to 1 that passes through the point 3, -5. Okay, well, first of all, if I'm gonna have to find a line that's parallel to 2x plus 4y is equal to 1, I have to find out what the slope of 2x plus 4y equals 1 is, right? So starting off, I'm going to subtract 2x from both sides. So I'm going to have 4y is equal to a negative 2x plus 1. This, divide both sides by 4. We'll have y is equal to negative 1/2 x plus 1/4. Okay, so what this means is that we're going to have a slope of negative 1/2, right? So let's, we'll do this. This means that we have a slope, m, right, of negative 1/2. Okay. Now, again, this problem is wanting us to find an equation of the line parallel. Okay, so we need to have the same slope. Easy peasy. All right. So next up, what we're going to have to do is we're going to use our equation generator, right? Remember the equation generator is the point slope form, right? So we are given a point and we discovered the slope. Okay, and then of course from that we'll go from point slope to slope intercept to standard. Okay, so if you forgot, let's go ahead and rewrite the point slope form. Let's see. Let's change this a little bit. Change that to blue. Okay, there. Now we can do point slope in yellow, or I'm sorry, yeah, point slope in yellow. So if you recall, the point slope form is y minus y1 is equal to m x minus x1. Okay, so if I plugged in everything I need to, my y, well, again, that just stays the same. My y1 is a 5, so y minus a negative 5 is y plus 5 is equal to my slope, which is negative 1/2, and then x minus 3. Okay, so that's point slope form. And then when we solve for y, we'll end up with the slope intercept form. Okay, so let's solve for y. Let's see. Let's denote this as point slope. All right, so we're going to solve for y, so let's go ahead and distribute that negative 1/2. So we're going to have y plus 5 is equal to a negative 1/2 x plus 3/2. Okay, and then we subtract 5 from both sides. So we'll have y is equal to a negative 1/2 x plus 3/2 minus 5. Okay, so now we have to write that 5 with a denominator of 2. Okay, so that would be, so if I rewrote the 5 with a denominator of 2, that would be 10, right? So that'd be 10 over 2, right? 10 over 2 is indeed the same thing as 5, right? Well, 3/2 minus 10/2, well, that's going to be a negative 7/2. So minus 7/2, right? And this is going to be the slope intercept form. Okay, and on the next page we're going to have to do the standard form. Okay, so going from here again, we have to put the x and y's on one side as well as, you know, clear any fraction, right? So we're going to have 1/2 x plus y is equal to a 7/2. We're going to multiply the entire problem by 2. Okay, so this is going to turn into x plus 2y is equal to 7. Right, and this is standard form. Right, and that's it. Wasn't too hard. Again, we just had to really dig deep, kind of, and figure out what was being asked. And once we figured out what was being asked, we easily solved it. Right, there was no hiccups along the way. Again, because I mean, once we did that equation generator, right, the point slope is just all downhill from there. Okay, let's see. All right, so but the next one we're gonna do is a parallel line, right? No, wait, that was parallel. Next one we're gonna do is perpendicular. That's what I meant to say. And indeed we are. All right. All right. So all this wants is us to put it in slope intercept form. Not bad. Again, it's just going from point slope to slope intercept, right? Sorry, slope intercept form is just basically in that form where we have y is equal to, right? So anyways, it says find the equation of a line perpendicular to the line. Well, this is pretty easy. So the slope of my original equation is, it looks like negative 5, right? Right. However, if I wanted to find the negative reciprocal, well, what is a negative reciprocal of negative 5? Well, that's going to be, right, we're changing it from a negative 5 to a positive 5, and then we're going to flip the fraction, right? 5 as a fraction is 5 over 1, so we're going to make it a 1 over 5. Okay, and then we're just going to use our equation generator, as we've talked about before, the point slope. So again, let's just go ahead and rewrite it. I like to rewrite it. This is one of the only formulas that I do like to rewrite and do underneath it, mainly because I feel like this one's really hard for students to memorize. I don't know. Anyways, so we're going to have y and then minus y1, so that's going to be y plus 1, right? My point, this is my point here. That's the point I'm using, and this is the slope I'm using. So I've got that, and it's equal to my slope of 1/5, and then x minus 3. All right, so let's clean this up a tad. Let's clean it up this way. So we're going to have y plus 1 is equal to 1/5 x minus 3/5. And then we're going to subtract 1 from both sides, so we'll continue down here. Y is equal to 1/5 x minus 3/5, and then we're going to have a minus 1. Okay, well, we're going to have to incorporate that 1 in here because we have to combine these two numbers. So how do we write the number 1 with the denominator of 5? Well, that's easy. That's 5 over 5, right? So we just write minus 5 over 5. Alrighty, well, what is negative 3/5 minus 5/5? Well, 3 minus 5 is 8, so we're going to have a negative 8/5. So we're going to have y is equal to 1/5 x minus 8/5. All right, and that's it. We found a line that is perpendicular to our original line. Right? I think that concludes today's lecture, actually. I told you today it was pretty short. That's it.